All right, in today's week, we are focusing on, I guess what we could say is an advanced R tutorial. And basically what we're focusing on today is we are looking at importing data external to the RStudio environment. So there are many kinds of data files that we can talk about, and many different data sources online. And I talk about that in a previous video. But today what we're going to do is we're going to go through a few of the ways in which you can load data that are not R-style data files. That is to say, it is not a data file that has a .r data suffix. That means it's kind of written as an R file. R recognizes it. It's owned by R in a way. We're going to load in other kinds of data files. We're not going to load in all of the kinds of data files, but we're going to basically load from the internet various types of files. And I'm going to, before we do that, you see some code here and you see some packages installed here. This code is a little bit fancier. If you look at you know, the loading of the packages, I have some if then dependencies. Don't worry about it. You can do the regular installation here. You can basically say, I want to install packages Mosaic. This is fine. This is a package we've used, of course, throughout the course. And I'll save that, and I'm going to just run that, just so we can do this. And we're going to also, just if we can have time, we're actually going to load some other some other packages, libraries. Sometimes we call them too, that as well. That's more of a programming term. You can use two functions here. You can use the require function or the library function. Remember that this is case sensitive, so we're actually going to require a built-in data package that I had found and that I had shared with you before, called the historical data package. And it's, as I said before, it's a great resource because it's a package of data sets. I get too excited about built-in data sets, but in this case, we're going to use a built-in data set because it includes a link and a description of the actual file online. And I'm also going to revisit using this data function that we talked about before, the data function. Use this to load built-in data sets in R. Okay, but let's do the libraries or loading the packages, right? You install packages, you load them. After you install them once, you don't have to do them again. R needs to be web aware to install. It does not need to be web aware to be loading the packages. That is, it does not need to be connected to the internet. So we'll do that. And you'll see my little conceit here. In the global environment, you see two data frames that are already installed. We don't see this one here, but I'm going to talk about a couple ways of reading in data files, and you actually get a little bit of a preview. But I want to put that below the fold, as they would say in newspaper speak. So I want to talk about types of data files you are expected to see online. First, a bit of terminology. Vocab. Tabular data. This means data is like a spreadsheet. I sort of ask myself, can you open it? Can you open it in a tab in a web browser? That's kind of my mnemonic for remembering this. By the way, if you notice, the second line of this comment is wrapped here on line 23. I skipped to line 24. That's a global option you can do. I don't want to confuse things, but you won't have that option unless you specify it. But the main point is the data you're going to analyze and use is called tabular data. Now, what does that mean? It's basically a spreadsheet. That's it. It has rows, it has columns, it's a square, it has an X and a Y axis. We call this tabular data because there are other kinds of data frames, databases that are not tabular. These often use more other kinds of data access programs. One of them is called SQL or SQL or MySQL. Or Access, I think, is another database function. There are also network type databases where, say they look at social networks, like if you look at the social networks on Facebook, those are not tabular databases because each data value is identified not by a variable, but by connections within a network. So those can be constructed into tabular data, and we'll talk a little bit about that. But the main point is you want to look for tabular data. That's what we're focusing on right now. It's sort of the classical structure of data sets in classical statistics. That doesn't mean in R you can't do the cool stuff and the visualization stuff. Because people are situated in time, space, and by various attributes that also change, and within social networks. And those can't necessarily be represented by one spreadsheet. Okay, in R speak, we'll talk about a data frame. This is R jargon, just to intimidate you or to exclude you. It's just in R speak, we'll talk about it. It's a data set, basically. Now, it's a data set recognized by R. All it means is that the number of columns, the number of variables, equal the number of rows. So basically, it means that R has recognized it as a data set, because you can also have a tabular format of data in R, but it's not recognized as a data frame, and this is called a matrix. A matrix, you might have heard of the movie The Matrix. Well, a matrix is a type of a data structure that is indexed by rows and by columns, but it's going to be much more messy. It's not recognized as a data frame. It might have, say, if you have four columns, A, B, C, and D, those might have, each column might have a different number of rows, a different number of observations. So it's more difficult to structure and organize. But just keep that in mind, that distinction. What you'll see online, what you will see if you search online, data sets. That's what they're going to call these things most of the time. Are surveys. Okay? Data sets, I think, is technically 2 words, but they'll call these data sets. Most often, it's going to be what we recognize as a data frame or as tabular data. That's 90% of the data that you'll see when you search online. But do a double take and make sure that that's the case. If it includes networks, if it includes spatial data, such as your latitude and longitudinal coordinates, that's for something other than statistics. That's for mapping. If it includes more complex data, such as text variables, like like the number of times you use tremendous in your tweets, then that might be tabular data, but it is not structured also in a way that we want. We want tabular data, but we also want one that doesn't include what are called string variables. And these are just text. We're not text mining. We're doing data analysis of structured data. So so you might want to say avoid network data, or you could say mapping or geocoded data, text mining data, not tabular. In other words, the question you can ask yourself is, can I read it in Excel hypothetically. I always misspell Excel. I'm not sure. I rarely use Excel myself. I've gotten used to it because I did work in policy evaluation, and they like pie charts and Excel. Okay, and you can use Excel too. But that's the question. Can you read it into Excel hypothetically? Okay, now types of data files you will encounter. Oh. And these are by the suffixes. So if you think about like a Word file ending in .doc or .docx, you're going to have these Excel files, right? So this is .xls for older ones, xls, I believe. But they're always going to have a dot, right? So it's going to have data.this, data.this. Look at those suffixes. That's tabular data. It might have different tabs or sheets. There are packages to read those tabs in separately. I would probably use Excel and just separate those out and either save them to your computer, or as we'll see below, you can also load data directly from the website. If it's a tabular data or if it's the right kind of data. And I'll show you that. You have to be connected to the internet. Okay, so other kinds are going to be statistical packages, such as Stata, not Stata. This means statistics data. That's very common among economists. That'll have a DTA suffix. We'll have SPSS, which is by IBM. It's common in more psych data. It'll have a .SPSS suffix, I believe. And then I think I talked about SAS, and I don't know what they are. I keep forgetting. DBAT or something like this. The point is, often if you look at those kinds of files, more and more data repositories will also include most data repositories will include what we call a delimited file. Delimited simply means if we have, say, columns, and we're going to combine these, and we'll say variable 1, variable 2, variable 3, then we're going to have row 1. It means it's going to be separated by, the information isn't just going to be like a 1, 5, 6. It isn't going to be like that. It could be, how do I put it? The data could be in tabular format, but the cells themselves are going to be separated somehow, not by rows, but by within rows. How do you separate the items in a row so that V1 corresponds to 1 and 4, and V2 and row 2 and row 3 doesn't like that either because I don't have a space. I'm using the combine function or concatenate function. What happens here is if you have a data set where you have rows and columns, the columns themselves may or may not have variable names, right? It might just be these, and this will be in a little table. So you might see something like this. These are two vectors here, and then we can basically combine those two. Those are called vectors, by the way. I'm sorry if I just used a term that was not useful, but basically, you know what I'll do? Rather than type it out like this, I'm going to comment this out because we are short on time. If we have something like this, where we have a data set, which could be in an Excel file, it could be in a text file, it could be in what is called a comma-separated file or comma-delimited file. So it could be .xls, it could be .csv. This is comma-separated values. That means the values themselves are separated by commas. That's what you see here. Or you could see a tab delimited file. It means if you press tab, that separates those two. Or it could just be some other generic indicator. Sometimes it doesn't matter given the functions we use. The point is, these rows themselves are not ambiguous for the computer to read in your file. What is ambiguous is what distinguishes between this item and this item, so we can pair up these columns. As I said before, sometimes the file itself will just include a matrix or a data frame with just the cells. So if you can open this up in a text file, and that's what it will look like. Or it might actually have the first row being variable names. You can cut and paste this into Excel, and it will ask you, when you do that, is the first row, are those variable names? Well, we call that first row column names typically, but in the command that we use, we also think of this as the header. This is the header for each column. And that's the function that we use in this read table function. And I like this function because it's pretty flexible. What we have here is we have this, this data set just based on line. It's a very simple data set. It's called 2 towns. It's a comma-separated file. And I'm using the read table function because even if you don't know what the separator is, it'll often be robust to reading in the data frame. You still have to check your data and take a look at it. But basically, the argument goes as follows. You have the name here, and I'm going to use the assignment operator, although you could use the equal sign. This is the name of the data frame when you read it into R. So I'm going to call it 2 towns. And then I use the read table function. And you can see that it gives you some help here. This is the name of the file I have here, including the suffix. All right, so include that .csv or .xls or whatever else you have. And notice, as I said before, you can include the path file or the link to the source online. And that's what we're going to do. Now, what I said before is I encourage you to save these files if you find them online, because the file, this link might be broken. So what you could also do is you could just save to your local desktop this. And then that would mean that your command would simply make reference to this. As long as you set working directory to wherever it is, where you are doing, where you do your project. Okay, you can just do that, and then you can just do that. That's probably easier because, in my view, if you want to save your file to your own computer. Now, sometimes files are really large, so why not take advantage of the fact that you can just directly download from online? I'm doing this in part as well because last time I had some internet connectivity issues. Now I want to, let's see. Yeah, I'll do this. I will just read in this file, but I want to show a couple things about this that are probably the most important arguments that you have. Within these parentheses, we're separating header equals true. That simply means that in a data frame, in a comma-separated file, such as this little example here, these column names, which are separated by commas, and the rows, which are separated by commas, show us that the first row is not informational. These do not include data. These are the names of the data. These are the names of the columns. So they should not be read in as data. They should be read in as column names. So if we do this, that means that we identify the first column to be variable names. Sometimes we don't know this, but the way you figure it out is you look at the source. You look at what is often called a code book. Here's the next rather bit of jargon, code book. This is a file or often a PDF or a .text file that says readme. What the codebook does is it basically describes what's in the data set. So the data frames or the data sets that you read into R by themselves will not carry enough information to tell you what is going on. That is why previously when we used the help function to understand even R's built-in data sets, because the data set itself does not carry information on what the variables mean. It does not carry the meaning. It carries the data. Right? So data is different than information, which is in the codebook, and then knowledge is what you get when you analyze and report and tell a story with the data. So here we have the read table function. I encourage you to look at this function. It's not the only one I have to emphasize. So it even has a URL option, but it is built in, and it's basically ubiquitous. So you have the name of the file here, and as I said, it can be a URL. Header can be false if you don't have names here. If the separator is not there, try that. The other thing I want to say is sometimes you'll have rows or cells within your data set where there are missing values that are either letters, like missing, or they are just nonsensical, in which case you want to, sometimes you will have missing values in your data frame, and if that's the case, then you want to include this na.strings equals na option. What this does is this tells us that if there are missing values, that is a space in your data frame. So in other words, if our comma delimited file had nothing for this cell, what it does is when it reads into R, it's not going to be just a blank space, or it's not going to change the height, the length of column 2 here. It'll actually replace it with NA, which in R's language, it means R recognizes this to be a missing value. This is something you don't encounter actually in the class. We actually removed the missing values because missing data is a big problem. It hugely biases a lot of results. There's no good solution around it. This is why modesty is central to doing statistics. But I want to emphasize the fact that you might have missing values. In this case, we don't have missing values. It's a simple example. But we do have, I do know that just from looking at the example, we do have the first row being column names. And we do know that it is comma separated. It's a CSV file. I'm going to tell R to do this. I could probably get away with not doing it. And you can try it multiple ways. But each way, and even if you think you're doing it right, double check. Inspect your data. Take a look at it. But we're going to do this. And it looks like we read it in. And it read in pretty quickly. And let's take a look at the data. The first the first variable is one called town. It has 2 levels. The second one is income. It is an integer or numeric variable. Integer, as I said before, is typically positive. Well, let's use the view function. Let's explore the data set for in a couple instances. And I'm actually going to, if I have some of these options, I'm going to give you a little trick of the trade. This is what I often do. You want to explore. So the next thing is once you load in external data in particular, you want to look and do a sanity check on your data. Assume you're wrong and you loaded the data incorrectly. We want to look at the structure. So we're going to call this data set X. And then we're going to look, so that basically gives us in the console the name. But let's take a look at a couple things. These are functions we've looked at before. Dimensions give us the number of rows in the columns. We use the end call, is that the right one? I apologize for forgetting that one. No. Okay, well, we'll try this. Let's try these, and then we'll do header X, and then with this head, and then tail. Tail X, and then we're going to do view X, and then we're going to do something called class X. Class tells us what it's called, because there, as I said before, you have data frames, you have other kinds of data sets, you have matrices, you have these things called values. These are actually vectors because it goes from 1 to 3 as 3 values. Class tells us what kind of object it is. These are all objects in our working environment. So here I have everything called X, but you're going to want to do this if you have multiple data sets as we have today. So we're going to just basically say, okay, we're going to call X 2 towns. So now it'll, for the rest of this, and I hope this won't be a problem because X is a very common value and might be used for other functions. But what we're doing is we're saying, for now, let's just call X 2 towns. And then we're going to do look at the first few rows of 2 towns, the tail of 2 towns, the dimension, the structure. We're going to view it. We're going to look at the class. This isn't probably the best order, but we'll probably do this first. These are more overall. And those are particular rows, but and then I believe it's I want to say, I'm sorry if I returns a matrix of integers indicating their column number. Yeah, no. Oh, I believe it's just names. I apologize, right? So this will give us the names of the header here that we have. Let's try that. We'll see what happens. I believe it's names. Regardless, if you're in doubt, by the way, use this view function. It'll just open up in a new tab here as a spreadsheet. So here we have our 2 towns data frame. We see it here. We believe it has two variables, 2 columns that have names. It has 202 rows and 2 variables. We believe it's going to be read in as a data frame. But I'm going to show you how this will work. Basically, I was able to do that with these functions using X. And now, if I want to switch it up to a different data set, as we see later, you can do that. But the point that we have here is, and you'll see it actually reads in X, so I should probably remove that later on. I made a copy of 2 towns. You can see that if we look at the last few, you'll see that this is what it looks like. And it doesn't look like there are any missing values, but let's take a look at the view here. And we'll just let's look at income. There are functions you can use where you can do NA, omits, things like that, but you can see that there are no missing values. You can also tell that this is a data frame, and I'll take you up to that function. If we look at this class, you'll see that it is a data frame. It's read in as that. The dimensions give us the number of rows and then the number of columns. That's in accordance with the global environment. Structure tells us generally what the structure of it is. I have an advanced tutorial that I mentioned that talks about the structure and class functions. This is useful for no matter what you're reading into R. But basically, this reads very much as you would here. This is kind of like this, kind of a graphical user interface version of the structure function. Names give us those names of those those columns. Those seem legitimate, seem fine, useful too, nice and short. And then we just look at the first few rows here. Looks like these are just numbers. There's nothing too bizarre here. And then if you want to do a double check, just see that. And the reason you want to do this is not only could you read in the data incorrectly, but also there could be weird things going on with the data that require additional cleaning. Look at my advanced tutorial playlist that's under R tutorials module. I'll show you how to do some cleaning operations. I'll also show you how to get help for that. But most of the time, you probably won't need to do that if you get data sources from the list of data sources I provide. Mostly because the government's already cleaned this. A lot of these are governmental databases. or widely disseminated ones. Okay, so as I said before, we don't really know what is going on here with this data set. I was looking at it earlier today, and I can tell you the backstory here for this data set is, where do I explain this? Well, you know what? I don't have the description, but you can probably go to the link there. But basically, it was an example of, you wanted to look at the difference in two means between two different towns A and B. And it's a good example of maybe what we had discussed before recording, which was what happens with this kind of data structure. What kind of test do I use? Well, it depends, as I said before, it depends on three things. The data you have at hand, because you can't ask questions and use statistical models that apply to data that don't exist. It also depends on the question. If you're interested in whether or not one town is greater than another, or if you're interested in the difference in two towns, then it's relevant. If you're interested in, say, maybe the difference in income between the two towns for below a certain threshold, then you subset the analysis and then look at the comparison of means between in the lower, say the lower half of the income distribution. That's a different question. It all depends. And the third point I mentioned was the model that you use, the statistical tool that you either have at your hand or that you know. In this class, we haven't looked at every one of the major statistical tools, and I have to say that's actually impossible to do. And in fact, for many different kinds of analyses, for the same question, you can actually look at it many different ways. So just keep in mind that there's a three-way battle going on. You could sort of say. We know what t-tests are. We can do one sample and two sample t-tests. We know what test of proportions are. We can do those. We can also do descriptive statistics. So keep those in mind. Okay, so here we read that in. Now, just for fun, we can just type this as false. Let's screw this up a little bit. And I haven't done this, but it's a good example of what happens if we say, don't do things perfectly. Whoops, I'm not doing that for the right one. I'm going to actually erase that. So let's say we have our two towns data set, and we're going to set this to false. I know it's after 6. I'm going to probably go to 6:30 because we spoke about 20 minutes. So if you need to go, that's okay. I'll continue recording. This is let's get rid of that, and then let's get rid of the what we know about the CSV file, and we'll see what happens. See what R does. You'll see an error here. You cannot connect because you actually don't have the actual URL. There's a 404 error. It often means you're not permitted. Sure. I appreciate those of you who are sticking around. I know we spent some time on the final project, but I hope my advice to some of you is informative to all of you. So what this clearly shows, obviously, is you got to have the right quote-unquote URL or path file here. So this is why by the way, I encourage you to, if you're downloading the file, put it in your working folder and then set your working folder. Then you won't have any difficulty searching for it, your file. We're going to set the header to false now. We're keeping everything all right. Look at this. We read in two towns now, but now we have this new two towns, and look what we have now. We have 203 observations instead of with two variables. And this is where it's useful to look at the data structure. And what we see here is that the variable names are not read in. By default, if you don't have variable names, the columns will be read in as capital V1, capital V2. And you can see this here. The first row is not a data set, or not data. So what happens then if you have, say, numerical data and then a string or a character? It's going to call the entire column something that is non-numeric. Look at this, a factor. that means it's read in incorrectly as a categorical data file. So the point is you really want to double check and see this is a case where I see, okay, if I didn't know this, then I'll set header to true. So we can do that. Now if we don't specify the separator, I believe this is the less egregious of all of the problems we have here. Well, no, that's not the case. But look what happens when you don't put in the separator. You're reading in basically a data frame with basically one variable. So I actually underestimated the importance of every command. I actually thought it was more robust. I was being a little arrogant here. But as a programmer, you have to realize you have to be very specific. Arguments and functions in are very literal. So what you want to do then is make sure that you have these elements correct. And if you want to double check, look at the code book, look at the source. So here you can look at, I think you can look at the website. Or you can also essentially just download a CSV file, because you can read CSV files in Excel. You know what? Since we are out of time right now, I think we'll stop here, and we will get to tomorrow. We're going to actually look at, well, you know what? I want to finish off with reading in a text file using the read table function. That way we got the read table function covered. I mentioned different kinds of files. A text file, however, is not delimited. It is simply quite often separated by spaces. So if I can double click on this, I'll actually show you what this file looks like, and I'll share you with this one. So another file that you might see, although it is less common, is essentially a text file. Text file is about as simple as you can get, but it's I'm gonna show it. I'll put it onto the desktop, and I'll open it and share that with you. And this is why I think I would say you can check within R, but you can also just check within, basically you can check just by downloading the file. If I can open it. So now you're going to take a look at this text file. And I'm going to stop. I'm going to do a new share, and I'll share with you this text file. If we had read in the CSV file, it would be read in simply as an Excel sheet. Excel files will read in a CSV file. It might ask you to save some things. But look at this. Here we have something that is kind of bizarre. The reason it's a little bit bizarre is this is actually William Gossett's analysis of, I believe, finger width and finger length. But he got it from a table from a book published elsewhere. So this is an example of a data set, first of all, that is not in tabular form, because we have a variable here in the x-axis, in the columns. We have a variable here in the y part, and then we have other variables that are basically a product or a consequence, or are defined as the intersection between each row and each column. This is not a tabular data form. This is what is called a relational database, because each cell is defined by its coordinates, or its relation between one indicator and another. I actually got this from the historical databases function, and but it's a good example of not only of a text file, but of one that actually is not appropriate for us. But that's okay, because I'm going to read in, still read it in just as an example. But I'll show you what this is. If I do just a delete, and then I do a tab, you can see that this actually might be tab delimited. If I do a space bar, it looks like that. So you still have delimiters in text files, but you don't need to read those in or necessarily for text files. I'm saying necessarily because there are always exceptions with data management techniques. Most often, from my experience, if it has a .txt ending, it means it is not defined as such, and you do not have to do anything with the data other than simply read it in. And I'll show that to you when I do the new share. So now I'm going to return us to RStudio. And here we're going to read in a text file. Here you have the URL. It's called criminal data from that. And there's a URL. You can download it. Now you can run it. And if you look at this data frame, there it is. And let's take a look at what it is. We're going to use our little tool here. This is almost a function. In R, you can do functions, which are basically little handy tools, bundled packages of tools. I'm kind of directing you to think that way by basically preventing you from replicating or repeating the same kinds of commands, especially if you have to do them over and over again. This is a fairly handy way to do it, as long as you remind yourself that this X is lying around, changing meaning each time. So now we're going to define this X as this criminal behavior, and then I will often do a capital DF for data frame, or maybe a .df to remind myself that the object I have is read in as a data frame. At least that's my attempt. Now you'll see the output here, but let's scroll up. Wait, am I sharing my screen? Yes, thank you. Okay, I just want to make sure I was sharing the screen. If we look at this, you'll see that it is in fact read in as a data frame. So this is where it gets a little difficult, because here we have a data frame because the number of rows equal the number of columns. But here's the problem. The data frame is not a tabular data frame. Well, technically it is, but it is a relational data frame or a relational database. It is not useful for us to do analyses because the observations are not independent. This is not a random sample. To give you more context and to remind myself what exactly these values are, we can actually use the historical data function, because you can also you read it in as a built-in data frame as well. And it looks like it is defined as data on 300 male criminals over 20 years of old undergoing their sentences in the chief prisons of New England and Wales. And the row names, the 42 row names, correspond to midpoints of intervals of finger lengths. So, okay, the midpoint of finger lengths are these rows here. This is the criminal database, so this is the midpoint. And the 22 column names correspond to body heights of 300 criminals. So you have the body heights, could be centimeters, it looks like, and then the midpoint of their finger lengths. And there's a kind of a nice little description about it. It's basically from his book. Basically, he wrote about it in his 1908 paper, which is famous because it talks about the probable error of a mean. It talks about standard error. So the cool thing is he takes a data set published by this gentleman, a metric system of identification of criminals, then produces a table by McDonald in the very well-known journal Biometrica, and says you can look at criminal anthropometry, and the identification of criminals, and then he claims this is the case, and then student does something else with the data. And I'll read you this. You can go if you need to, but it's useful for looking at history, but also understanding the value of using data that may seem old or outdated. So what did he write? Student wrote, before I had, and later on after he published his 1908 paper, before I had succeeded in solving my problem analytically, the problem I believe of the problem of the standard of errors, I had endeavored to do so empirically. Good example of how hands-on data analysis works. The material used was a correlation table. Not exactly a correlation table, but we'll get there. Containing the height and left middle finger height of the person and the left middle finger measurements of 3,000 criminals from a paper by da-da-da. The measurements were written out on 3,000 pieces of cardboard, which were then thoroughly shuffled and drawn at random. As each card was shown, its numbers were written down in a book, thus which contains the measurements of 3,000 criminals in a random order. Finally, each consecutive set of 4, taken as a sample, 750 in all, and the mean, standard deviation, and correlation of each sample was determined. So it seems like they had drawn samples here. Now, without replacement. Yeah, so interesting enough, he's using it as an example of basically as a data set where you could take samples of 4. The difference between the mean of each sample and the mean of the population, so this is, would be the, I don't know, overall correlation, I suppose, was then divided by the standard deviation of the sample, giving a z in section 3. So it's a little complex, but I believe those numbers here correspond to the draws of the random samples. Not 100% sure. But the point is he took those data, used those, and rather than examine the correlation between height and finger length, he looked at those to create basically a matrix, a table of in which you could identify the random draws or the random measurements of subsamples taken. And then he looked at those subsamples to look at the standard error, to develop his concept of the standard error. So interesting enough, he started from data and went to theory. That happens often in statistics. It is an applied science. We had Gossett talking about Guinness. We had other people talking about other data problems. And here's a case where here we had random samples, and that led to this particular issue. This is why I think it's important to not only look at older data, but to also examine it. So the table is in fact, as the other note says, is in fact page 216 and not page 219 in McDonald 1902. In the McDonald table, the middle finger lengths were given in millimeters and the heights in feet and inches intervals. Okay, both of which are converted to centimeters here. The midpoints of intervals were used, so that's probably the median. McDonald is credited as the source of credited the source of the data as follows: quote, "The data on which the memoirs based were obtained through the kindness of Dr. Garrison of Scotland Yard." He pointed out on page 179, the forms were drawn at random from the mass on the office shelves, and thereby dealing with a random sampling. So the original data here are located apparently from an R source in France, some statisticians in France. But you'll see that here you have an original question on the system of identification. So, yeah, to be honest, I'm still not 100% sure what the numbers mean here. Let's see. The numbers were drawn out in a book, so it looks like these might be numbers that are randomly drawn that identify the sample. So if you have a 1 here, that's 1 sample. Although it looks like there are more than 4 ones. Whatever the case may be, this is certainly not the data set format that we want. And it's considered a tabular data frame because it's not X number of different samples, X number of different data sets. It is actually all of the data sets relationally structured by both the variables and by the cell indication, the cells which indicate the sample from which it is drawn. Now, if you look at the help file, I believe there's some code here to clean it up, to basically collapse it and turn it into the original data set. But yeah, that's, I don't think we have to say anything else here, except I just want to make sure if we read in the data frame. Oh, this is what I have. I have the McDonald DF. You have 3,000 observations with 2 variables. This is the actual database that I have. This was from the built-in R function. So if you want to read in built-in data, this is my final review. So we talked about read table and how we can read in basically CSV files, text files, but we have to be careful about what to do. I showed us how we can examine such data and how we must examine such data iteratively to know what's going on. I defined some key terms, including tabular data, and then comma delimited files. And I'm going to say now we can also read in Gosset's data using the hist data function. So if we do this, this will give us information on that, on the data sets here. And you can see that McDonald's data on finger and length of criminals used by Gosset in 1908 is structured as a relational database. But here it is built in as a data frame, And I'm going to read that in. So you just type in data like this, and it'll take a little while. It's reading in, but you saw that it actually included 2 numeric variables with 3,000 columns. Yeah, 3,000 rows. 2 columns, 3,000 rows. And that's the data as they were originally structured, restructured by someone else, analyzed by Gosset, who then realized, okay, sampling distributions can be, the variation in sampling distributions randomly sampled can be represented by the error of the mean, the standard error of the mean. And you can analyze that yourself if you're interested in either in criminality and the finger length, and you could re-examine those data or look at other data. So I hope that was useful. I guess I did say we're going to go to 6:30 or so, and I guess I will, because I did want to get to this. We talk about different data sets. If you're interested in it, you can read in different data sets if you can't find a CSV file version. I read that in already, I believe, as my data right here. And basically you use the library function. So you first have to install this package called foreign. Basically what it means is they include functions to make calls up to compiled code. That's not it, it's the capital F. Why is it not working? Install, hold on for a second, foreign. Okay, well, I'm trying to remember why foreign doesn't read in there. I believe it's because it's, let's see, help packages. I believe it's the car package, but let me make sure. Sorry, did I install the foreign package? Yeah, so you do want to install this foreign package. I'm not sure why it's not giving me help here, but I'll click on it if you need help. It'll read in all these kinds of data files. You just have to do read dot whatever it is. Read.dta is what we have here. They call them binary files for whatever. You can also read in other kinds of databases. Here's the SPSS file I gave. Minitab is a lesser common type. SAS is very, I guess, common. I thought there was a DBAT file, but maybe not. Okay, well, you can read in lots of different kinds of data formats, but the point is, most often you're probably going to run into Stata or SPSS. So we'll read in this data. We'll try to reread in this data file, just so I can show you. So once you have the package installed, then all you have to do is, I'm not sure why there's an error there. Okay. Yeah, okay, so this is how you do the document. Yeah, you have to do help on the particular function. That's right. That's a little confusing here. So just keep in mind that if you want help on the particular function here, you have read.dta. You can also do help documentation on other ones, so that I'll do that. But you can just also go to your list of packages and just double click on foreign. And it'll give you help here. So you also might want help. Oops, I made a mistake here. Oops, it doesn't want me to type. Double click on the console, help.spss. And then you can just get that help file going. I typed help here. Some of these might have other arguments or options that are required. If you look at use value labels, you might want to set that to false. It gets complex. So if you can find a CSV file, you're better off. But it's also quite easy quite often, and I'll show you what happens. Let's actually clear out my environment, and we'll take the time to do this. And then we're going to end on that. There we are, pretty quick. Let's view this. I called it my data. Oh yeah, because it's a baby data set. That's why I loaded it in. Couple things here. In most stats packages, there will be a variable label. It'll tell us what it is. And we don't have that in R, so what does it do with variable labels? It'll have this junk down here. It'll have these attributes here. You don't need to really worry about that, except if you want to apply those attributes, later, you can do that. And if you want additional information. So look at this. This was apparently made in 2009. It was used, looks like value. So in Stata factor variables, value, those factors can be labeled as well. It doesn't look like those are the case. This is almost like a code book because it provides you with some additional information. So it gives you the types of the variables, but it also gives you the version of the software you use. So this is looks like it's Stata version 8. So if you need to know that, it's helpful. Variable labels is probably the most important one if you don't have the code book. So the first variable cars is the number of cars. Second one is number of people in a household. So that's basically the way you can read in almost all data sets, I think. If you have even data that are not in tabular form, you can still read those in. So what do you do? Reviewed importing delimited files. We learned how to import delimited files, how to import text files, learned how to use and reuse chunks of code for data sanity checks. Right, this is the sort of like when I assigned X to the data set name. And then I provided a bunch of commands. I copy and paste those to check it out. And then finally we used learned the foreign package to import other data sources. And then on the conceptual, learned keywords and types of data to find online. Regardless, just double check and import stuff. And I would have to say, historically, we learned that no matter what you may think, the next great discovery could be around the corner. Gossett wrote a long time ago, but he was using a data set of a data set of a data set. Scotland Yard produced stuff. They probably found insights from that, I guess. I'm not sure if that's even true. It's published, then produced in another book, and then Gossett did something else and came up with a theoretical discovery that we still use and teach today. So don't be too hard on yourself. And don't think that just because data are old, that it can't be revisited. Okay, that's it I think I wanted to be complete. I promised you one thing, and then I said, okay, we'll just finish this through. So that's it, I think. So after this, you should be able to read in data files. Now, those aren't the only ways to read in data files. You might also want to look at other packages. Well, actually, I'll do this. Other ways to load in data, you could do this. I know I kind of might have conned you here, but you might want to just check that out. Now, some of these, this is a base function. This is what we learned. The rest of these might be the foreign package. But this read R function is actually something that's relatively new. So if you want to learn new functions or other functions, you can look up the read R, and then you can look up read.csv, and then read.csv too, and probably a bunch of other things. We didn't cover all the ways you can upload data, but that's pretty good. I believe you can even do something where you copy and paste and save to your clipboard. But these are useful. The read R function I would encourage you to look at if you're really into coding. But when in doubt, I'd say when in doubt, use GUI, and that's graphical user interface. So we'll show you how to do that. We'll do this from a text file, and we'll use the reader function. And you know what I'm going to do? Actually, I'm going to type in the URL. I know this is going on far too long for some of you, so please go if you need to, and we will record and post this ASAP. I just would prefer to be complete just so we can do that. So we're going to use this read R function, and we're going to type in the URL, and then we'll import. See what happens. Object data set not found. So you'll see there's some trial and error. If we do the base function, it might be a little bit easier. We use the criminals data set here. This is the gossip one. I'm just going to import it. I don't care. Okay, so the base function seems to be a little bit easier. Read R is a new one. You can try other kinds of data sets as well. But there you go. So that can work too. I encourage the code because it just helps you to replicate and to redo things. All right, thank you so much. I appreciate all of your help, and that's it.
Thank you, Nathan.
Thank you. So